Starting with the Su-1, the first aircraft from the Sukhoi Design Bureau, which flew in May 1940. It was designed as a high-altitude interceptor for the Soviet Air Force with a pressurized cockpit. The aircraft used a Klimov M115P engine, producing 1,050 horsepower. Only a single prototype was built before the program was canceled due to poor performance. The Su-1 failed to meet its design specifications and was abandoned in favor of competing designs. The Su-2 entered production in 1940 as a light bomber and reconnaissance aircraft. It featured a mixed construction with wooden wings and a steel tube fuselage. The aircraft used a Tumansky M88B radial engine, producing 1,100 horsepower. A total of 910 were manufactured between 1940 and 1942. The Su-2 saw extensive combat during the early stages of Operation Barbarossa, before being replaced by more capable designs. The Su-6 was developed as a heavily armored ground attack aircraft during World War II. It featured thick armor plating protecting the engine, cockpit, and fuel tanks from ground fire. The aircraft mounted a 37mm memory cannon and could carry up to 400 kilograms of bombs. Only 33 production aircraft were built before the program was canceled in 1943. The Ilyushin Il-22 Sturmovik proved superior and received priority for production resources. The Su-7 became Sukhoi's first successful jet fighter, entering service in 1959. It was designed as a fighter bomber capable of delivering nuclear weapons at low altitude. The aircraft used a single Lyulka AL-7F turbojet engine, producing 10,000 kilograms of thrust with afterburner. Over 1,800 were built in the Soviet Union with additional licensed production in Czechoslovakia and Poland. The Su-7 served in combat during the Indo-Pakistani Wars, the Yom Kippur War. The Su-9 was developed as a single-seat, all-weather interceptor in the late 1950s. It featured a delta wing design and nose-mounted ARP-9 Sapphire radar for target acquisition. The aircraft used a single Lyulka AL-7F engine and could reach speeds of Mach 1.8. A total of 1,100 were produced between 1959 and 1962. The Su-9 was designed specifically for Soviet air defense forces to intercept Western bombers. The Su-11 was an improved version of the Su-9 interceptor design. It featured upgraded ARP-11 Oriole radar with better range and tracking capability. Production began in 1962 and totaled approximately 600 aircraft. The Su-11 could carry K-8 air-to-air missiles for beyond visual range engagements. The aircraft remained in service with Soviet air defense forces until the late 1970s. The Su-15 was developed as a twin-engine interceptor to replace the Su-9 and Su-11. It first flew in May 1962 and entered service in 1965. The aircraft featured two Tumansky R-11 F2S-300 engines, producing a combined 13,500 kilograms of thrust with afterburner. Over 1,290 were built with production ending in 1979. The Su-15 gained notoriety for shooting down Korean Airlines Flight 007 in 1983. The Su-17 was a variable geometry wing development of the Su-7 fighter bomber. The wings could sweep between 28 and 63 degrees to optimize performance for different flight regimes. First flight occurred in August 1966 with operational service beginning in 1970. A total of 2,867 were produced, including export variants designated Su-20 and Su-22. Su-17 saw combat in Afghanistan, Syria, Libya, and Iraq throughout the 1980s and 1990s. Su-24 was designed as a supersonic all-weather attack aircraft with terrain-following radar. It featured side-by-side seating for the pilot and weapons systems officer. The aircraft used two Lyulka AL-21F-3A turbojet engines, producing 11,200 kilograms of thrust each with afterburner. Production began in 1971 and totaled over 1,400 aircraft by the time manufacturing ended in 1993. The Su-24 remains in service with Russian and several other air forces conducting strike missions. The Su-25 entered service in 1981 as a heavily armored close air support aircraft. It was designed specifically for low-altitude ground attack missions against armored targets. The aircraft featured titanium armor, protecting the cockpit and critical systems from ground fire up to 23 mm caliber. Over 1,000 were built in the Soviet Union with additional production in Georgia. The Su-25 has seen extensive combat in Afghanistan, Chechnya, Georgia, Syria, and Ukraine. The Su-27 was developed to counter American F-15 and F-16 fighters in air superiority missions. It first flew in May 1977 and entered operational service in June 1985. The twin-engine aircraft featured advanced aerodynamics with leading-edge root extensions and widely spaced engines. Over 680 were built in Russia, with continued licensed production in China as the Shenyang J-11. The Su-27 established multiple climb time and altitude records during flight testing. The Su-27K was the carrier-based variant developed for Soviet naval aviation. It featured folding wings, reinforced landing gear, and an arrestor hook for carrier operations. The aircraft was redesignated Su-33 in 1998 after the Soviet Union collapsed. A total of 36 were built for operations from the Admiral Kuznetsov aircraft carrier. The Su-33 uses a ski jump takeoff configuration rather than catapult launch. The Su-30 was developed as a two-seat long-range interceptor and strike aircraft. It featured enhanced avionics and the ability to conduct both air-to-air and air-to-ground missions. The aircraft entered service in 1996 with various specialized variants for export customers. Over 630 have been produced, including the Su-30 MKI for India and Su-30 MKM for Malaysia. The Su-30 can perform the Pugachev's Cobra maneuver, demonstrating exceptional agility. The Su-32 was the export designation for a variant intended for maritime strike missions. It featured side-by-side seating and specialized avionics for anti-ship operations. The aircraft was later redesignated Su-34 fullback for Russian service. Development continued through the 1990s with operational deployment beginning in 2014. The Su-32 designation is rarely used, with most variants called Su-34. The Su-34 entered full operational service in 2014 as a fighter-bomber replacement for the Su-24. It features a distinctive platypus nose with side-by-side crew seating and armored cockpit. The aircraft uses two Saturn AL-31F turbofan engines producing 12,500 kilograms of thrust each with afterburner. Over 150 have been built, with production continuing for Russian aerospace forces. The Su-34 has conducted extensive combat operations in Syria and Ukraine. The Su-35 represents an advanced development of the Su-27 design with enhanced avionics and engines. It features thrust vectoring nozzles allowing extreme maneuverability in combat. The aircraft uses two Saturn AL-41F1S engines, producing 14,500 kilograms of thrust each with afterburner. Over 130 have been built since production began in 2009. The Su-35 has been exported to China, Indonesia, and Egypt. The Su-37 was a technology demonstrator derived from the Su-35 design. It featured canard foreplanes and three-dimensional thrust vectoring for enhanced agility. The aircraft first flew in April 1996 and demonstrated extreme maneuvers at air shows. Only one prototype was built before the program was terminated in 2002. The Su-37 influenced development of thrust vectoring systems for later Sukhoi fighters. The Su-39 was an upgraded variant of the Su-25 attack aircraft with enhanced avionics. It featured improved navigation systems and the ability to use precision-guided munitions. The aircraft was designed for export markets in the late 1990s. Minimal production occurred, with most customers preferring standard Su-25 variants. The Su-39 designation saw limited use, with few aircraft manufactured. The Su-47 Burkut was an experimental fighter featuring forward-swept wings. The aircraft first flew in September 1997 as a technology demonstrator for advanced composites. The forward-swept design provided exceptional maneuverability at high angles of attack. Only one prototype was built, with the program ending in 2006. The Su-47 technologies influenced development of the later Su-57 fifth-generation fighter. The Su-57 is Russia's fifth-generation stealth fighter designed to counter American F-22 and F-35 aircraft. It features internal weapons bays, advanced radar systems, and reduced radar cross-section. The aircraft uses two Saturn AL-41F1 engines, producing 14,500 kilograms of thrust each with afterburner. Production began in limited numbers, with approximately 20 built as of 2024. The Su-57 has seen limited combat deployment in Syria for operational testing. The Su-80 was developed as a twin turboprop light transport and passenger aircraft. It featured a high-wing design with a rear loading ramp for cargo operations. The aircraft first flew in September 2001, with certification obtained in 2004. Only 5 production aircraft were built due to lack of orders. The Su-80 program was effectively abandoned by 2012 with no further production. The Su-2 was mentioned earlier, but had variants that deserve separate recognition. The Su-2R was a reconnaissance variant with specialized camera equipment installed. Limited numbers were produced alongside the standard bomber variant. These aircraft conducted photographic reconnaissance missions during the early war years. Most were lost during the German invasion before their full potential could be realized. The Su-6 variants included the Su-6M71 with a more powerful AM-42 engine. This version provided improved performance over the initial production model. Testing showed better speed and climb rate compared to earlier variants. The program was still cancelled despite these improvements due to IL-2 production priority. Few Su-6M71 aircraft were completed before cancellation. The Su-7B was the fighter-bomber production variant that saw the most service. It featured reinforced wing hardpoints for carrying bombs and rockets. The aircraft could carry up to 2,000 kilograms of external ordnance. Over 1,200 Su-7B variants were built for Soviet and export customers. This version equipped fighter-bomber regiments throughout the 1960s and 1970s. The Su-7BM was an improved fighter bomber with upgraded avionics and weapon systems. It featured better navigation equipment and improved weapons delivery capability. Production totaled approximately 400 aircraft in the late 1960s. The Su-7BM served with Soviet tactical aviation units and several export customers. India operated the type extensively during conflicts with Pakistan. The Su-7BKL was designed for operations from unprepared airfields with rough surfaces. It featured blown flaps and a braking parachute for short field performance. The aircraft could operate from grass or dirt strips without significant degradation. A total of 197 were built for Soviet frontal aviation units. The Su-7BKL provided tactical flexibility for forward deployment. The Su-7U was the two-seat trainer variant developed for pilot conversion training. It featured tandem seating with dual controls for instructor and student. The aircraft maintained combat capability despite the training configuration. Over 50 were built to support operational Su-7 squadrons. The Su-7U remained in service throughout the operational life of the fighter-bomber variants. The Su-9U was the two-seat training variant of the Su-9 Interceptor. It featured a second cockpit for instructor pilots during conversion training. The aircraft maintained full interceptor capability including radar and missile systems. Limited production occurred with most training conducted on operational single-seat aircraft. The Su-9U supported air defense units equipped with the standard interceptor. The Su-11UM was a conversion trainer variant of the Su-11 Interceptor. It featured tandem seating while retaining combat systems for realistic training. The aircraft allowed instructors to monitor student performance during intercept missions. Small numbers were produced to support operational Su-11 squadrons. The Su-11UM helped transition pilots to the Delta Wing interceptor configuration. The Su-15UT was the trainer variant designed for Su-15 pilot conversion. It featured a second cockpit positioned behind the standard pilot position. The aircraft maintained full weapons capability, including missile systems. Production totaled approximately 175 aircraft to support operational units. The Su-15UT remained in service alongside frontline interceptor variants. The Su-15TM was an improved interceptor variant with upgraded radar and missile systems. It featured R-98TM radar, providing better detection range and tracking capability. The aircraft could carry R-60 and R-98 air-to-air missiles for various engagement scenarios. Over 400 were built as upgrades of earlier Su-15 variants. The Su-15TM represented the final major upgrade of the interceptor design. The Su-17M was the first production variant of the variable geometry fighter bomber. It featured improved avionics compared to the Su-7 from which it was derived. The aircraft entered service in 1972 with Soviet frontal aviation units. Production totaled approximately 200 aircraft before improved variants appeared. The Su-17M established the variable wing fighter bomber concept for Soviet tactical aviation. The Su-17M2 featured upgraded weapon systems and improved navigation equipment. It introduced the ability to carry laser-guided bombs and air-to-air missiles. Production began in 1974 with approximately 300 aircraft built. The Su-17M2 saw combat in Afghanistan with Soviet forces. Export variants were designated Su-20 for downgraded versions. The Su-17M3 was a major upgrade with new radar and expanded weapons capability. It featured improved terrain-following systems for low-altitude penetration missions. The aircraft could carry a wider variety of guided and unguided munitions. Over 500 were built between 1976 and 1981. The Su-17M3 equipped numerous Soviet tactical aviation regiments throughout the 1980s. The Su-17M4 was the final production variant with comprehensive avionics upgrades. It featured digital fire control systems and improved electronic warfare equipment. The aircraft entered production in 1981 with approximately 850 built. The Su-17M4 remained in Soviet and Russian service until the late 1990s. Export variants designated Su-22M4 served with multiple air forces worldwide. The Su-17UM was a two-seat trainer variant developed from the Su-17M. It featured tandem seating while maintaining combat capability. The aircraft allowed conversion training for pilots transitioning to variable geometry wings. Production totaled approximately 90 aircraft to support operational squadrons. The Su-17UM served throughout the operational life of single-seat variants. The Su-17UM3 was an improved trainer corresponding to the Su-17M3 fighter bomber. It featured upgraded avionics matching the single-seat variant. Aircraft provided realistic training for advanced weapons delivery techniques. Over 100 were built between 1978 and 1982. The Su-17UM3 supported units equipped with the M3 fighter bomber variant. The Su-24M was an improved variant with enhanced weapons delivery capability. It featured upgraded navigation systems and improved radar for terrain following. The aircraft could employ precision-guided munitions, including laser and TV-guided bombs. Over 900 were built as new production and upgrades of earlier variants. The Su-24M remains in service with Russian and several other air forces. The Su-24M2 was a comprehensive upgrade program applied to existing Su-24M aircraft. It featured modern avionics, GPS navigation, and compatibility with precision munitions. The upgrade extended service life and improved combat effectiveness. Approximately 100 aircraft were upgraded beginning in the late 1990s. The Su-24M2 continues operating in Russian service, conducting strike missions. The Su-24MK was an export variant designed for foreign customers. It featured downgraded avionics and weapon systems compared to Soviet versions. The aircraft was exported to Algeria, Iran, Iraq, Libya, and Syria. Production for export totaled approximately 200 aircraft. The Su-24MK designation indicated the monkey model configuration for export. The Su-24MR was a tactical reconnaissance variant with camera and sensor systems. It featured specialized equipment for photographic and electronic intelligence gathering. The aircraft replaced camera equipment in the weapons bay area. Over 100 were produced for Soviet tactical aviation reconnaissance squadrons. The Su-24MR conducted intelligence missions throughout the Cold War and after. The Su-24MP was an electronic warfare variant designed for radar suppression missions. It featured specialized jamming equipment and anti-radiation missiles. The aircraft could suppress enemy air defense systems supporting strike packages. Limited production occurred with fewer than 50 built. The Su-24MP supported tactical aviation operations requiring electronic warfare capability. The Su-25K was the baseline export variant of the attack aircraft. It featured simplified avionics and weapons systems compared to Soviet versions. The aircraft was exported to numerous countries including Afghanistan, Angola, and Iraq. Over 180 Su-25K variants were built for export customers. The designation indicated the commercial export model configuration. The Su-25UB was a two-seat trainer variant developed for pilot conversion. It featured tandem seating with the instructor position elevated for better visibility. The aircraft maintained full combat capability, including armor protection. Over 80 were built to support operational Su-25 squadrons. The Su-25UB continues serving in training roles with multiple air forces. The Su-25T was an upgraded variant with enhanced anti-tank capability and improved sensors. It featured the Shkval targeting system providing precision weapons delivery. The aircraft could employ laser-guided missiles against armored targets. Limited production occurred with approximately 8 built before funding constraints. The Su-25T program was largely superseded by the Su-25SM upgrade. The Su-25TM was a further development featuring comprehensive avionics upgrades. It was later redesignated Su-39 for marketing purposes. The aircraft featured satellite navigation and compatibility with modern precision munitions. Minimal production occurred due to economic constraints in the 1990s. The Su-25TM represented advanced capabilities that were not fully realized. The Su-25SM was a modernization program applied to existing Su-25 aircraft. It featured upgraded navigation, communications, and weapons systems. The aircraft received compatibility with modern guided munitions, including laser and satellite-guided weapons. Over 80 were upgraded beginning in 2005. The Su-25SM continues operating with Russian forces in combat operations. The Su-25SM-3 was a comprehensive modernization providing advanced capabilities. It featured new multifunction displays, satellite navigation, and expanded weapons compatibility. The upgrade included improved engine performance and extended airframe life. Approximately 50 aircraft were upgraded to this standard. The Su-25SM-3 represents the most capable variant currently in service. The Su-27P was the initial production interceptor variant for Soviet air defense. It featured air-to-air missile armament and radar optimized for interceptor missions. Production began in 1985, with approximately 400 built. The Su-27P equipped air defense units responsible for protecting Soviet airspace. This variant lacked ground attack capability, focusing purely on air superiority. The Su-27S was a multirole variant with enhanced ground attack capability. It featured improved avionics and compatibility with air-to-ground weapons. The aircraft entered production in 1988 with approximately 280 built. The Su-27S equipped frontal aviation units requiring both air-to-air and air-to-ground capability. This variant became the standard production model. The Su-27SK was an export variant designed for foreign customers. It featured downgraded radar and avionics compared to Soviet versions. The aircraft was exported to China, Vietnam, and other countries. Over 100 Su-27SK variants were built for export. China later produced unauthorized copies as the Shenyang J-11. The Su-27UB was a two-seat trainer variant with tandem cockpit configuration. It featured dual controls while maintaining combat capability. The aircraft provided conversion training for pilots transitioning to the Su-27. Over 100 were built to support operational units. The Su-27UB continues serving in training roles with multiple air forces. The Su-27SM was a modernization program applied to existing Su-27 aircraft. It featured upgraded radar, avionics, and compatibility with modern weapons. The upgrade included R-77 active radar missile capability. Approximately 60 aircraft were upgraded beginning in 2002. The Su-27SM extended the operational life of the fighter design. The Su-30M was an early two-seat development intended for export customers. It featured enhanced avionics and multirole capability. Limited production occurred before more advanced variants appeared. The designation was later reused for different configurations. Early Su-30M aircraft were essentially Su-27UB variants with minor upgrades. The Su-30MKK was developed specifically for Chinese requirements. It featured enhanced ground attack capability and compatibility with Chinese weapons. The aircraft could employ precision-guided munitions and anti-ship missiles. A total of 76 were delivered to China between 2000 and 2004. The Su-30MKK equipped Chinese naval aviation units. The Su-30MKI was developed for the Indian Air Force with advanced avionics. It featured French and Israeli systems including helmet-mounted displays and targeting pods. The aircraft incorporated thrust vectoring engines for enhanced maneuverability. Over 270 have been delivered to India with licensed production continuing. The Su-30MKI represents one of the most capable flanker variants. The Su-30MKM was developed for the Royal Malaysian Air Force. It featured systems similar to the Indian variant, including thrust vectoring. The aircraft incorporated canard foreplanes for enhanced agility. A total of 18 were delivered to Malaysia between 2007 and 2009. The Su-30MKM represents a highly customized export variant. The Su-30SM was developed for Russian forces, combining features of export variants. It featured systems from the Su-30MKI adapted for Russian requirements. The aircraft entered service in 2012 with over 130 delivered. The Su-30SM equipped both Russian aerospace forces and naval aviation. Production continues with additional orders placed. That concludes our look at the Sukhoi aircraft family. As is standard for this channel, I only cover aircraft that reached large-scale production, excluding prototypes and limited experimental models. Thank you for watching, and I hope to see you again.